Okay, so in this video, we are going to factor polynomials using the sum and the difference of cubes. So it's going to be a lot like our difference of squares method, but with cubes. So cube meaning that there are 3 of them. So in order to use the sum of cubes method of factoring, the problem must meet the following criteria. So it needs to be a binomial, which remember that's having 2 terms. It needs to have an addition sign. And it needs to have 2 perfect cubes. So on your factoring chart, that purple sheet from last trimester or last unit has all the perfect squares and all the perfect cubes on it. So use that to help you with this. So if an exponent can be divided by 3 evenly, then it's a perfect cube. So like with the perfect squares, it needed to be divided by 2. Then it was a perfect square. This one, if it's divided by 3 evenly, then it's a perfect cube. So the factors are going to look like, so you're going to have x plus y, x squared minus x times y plus y squared. That will make more sense here in a minute when we do some examples. Okay, so now for difference of cubes, in order to use difference of cubes, factoring the problem must meet the following criteria. So again, it needs to be a binomial, which is your 2 terms. But with this being difference, it needs to be a subtraction sign. And you need to have 2 perfect cubes. If an exponent can be divided by 3 evenly, then it's a perfect cube. Okay, so this time your factors are going to look like x minus y, then x squared plus x times y plus y squared. So the only difference are the signs in the first one and then the first sign of your second one. So just be careful of that. Okay. Okay. So, let me see if I can find that chart. So here is mine that I made yours with. So first, let's just go through and say if they're sum of cubes or difference of cubes, or if that even works at all. So first of all, 8 is a perfect cube, and so is 27. And then 3 can go into 3 evenly, and and 3 can go into 9 evenly. So because this is an addition sign, this is going to be sum of cubes. Okay, and 125 and 64. So this is going to be our difference of cubes. Now 121 and 9 are not perfect squares. This is actually our difference of squares method that we did in the last unit. So just to give you a reminder, so this is where we would square root both of them. So one set would be plus and one would be minus. So the square root of 121 is 11. And then you would take half of your x term, or your exponent, so x to the 4th and x to the 4th. Then the square root of 9 is 3. Then half of your y would be 6. Okay, so 512 and 1. And both of our exponents can be divided by 3, so this is going to be our difference of cubes. 216 and 8, and then both those can be divided by 3, so this is our sum of cubes. Okay. Okay, so first thing that I like to do is figure out what our x and our y are going to be. So just a reminder that your sum of cubes is the x plus y, x squared minus x times y plus y squared. And then your difference of cubes is your x minus y, x squared plus xy plus y squared. Okay, so first I like to go through and figure out what x and y are. So the cube of 8, so if I'm looking at this chart, cubed is 8, so that number would be 2. And then you divide your exponent by 3, so 3 divided by 3 is going to be 1. Then 27 is 3 cubed, so 3y, and then divide your 9 by 3, which is 3. So if I do that again for this one, my x and my y. So 125 cubed is 5. And then a, and then 6 divided by 3 is 2. Then 64 is 4 cubed, so 4b, and then 15 divided by 3 is 5. So now you plug these into your equation, either your sum of cubes or your difference of cubes. So for a sum of cubes, I've got x plus y. So my x term is this 2x plus my y is 3y cubed. So then you have to square your x term because this is x squared. So 2 squared is 4, And then x to the first power, so I would have to square this, would be x squared. So this is where it can get a little tricky. Minus, then we're multiplying these two together. So 2 times 3 is 6, and then just your xy cubed. Plus, then your y squared. So 3 squared is 9, y. And then when you square this, you multiply your exponent. So 3 times 2 is 6. And you can always check your answer by using your box method of multiplying these back together to see if you get your original answer. And it should work if you did it correctly. So now let's do this one. So this one's our difference of cubes. So our x term is the 5a squared minus your y, so that's 4b to the 5th. Then your x squared term, so if I square this, 5 squared is 25. Then a, then squared, so I would multiply my exponent, so 2 times 2 is 4. Which you should, if you check these, your a's, the 2 and the 4 make 6, which is what you have here. And plus these being multiplied together, so 5 times 4 is 20. Your a squared b to the 5th plus your y squared. So 4 squared is 16, and b, and then 2 times 5 is 10. So again, your b's, the 5 and the 10 make the 15 that you have here. You can also check this by 5 times 25 is 125, and then 4 times 16 is 64. So kind of just ignoring this term, you should be able to check to see if you got the right answer. So go ahead and try these two on your own. Let me know if you've got any questions, and I will see you in the next video.